Whoa, that's loud. So just before we get started, let me remind you that problem set number 1 will be due on Tuesday as you arrive for class. So there will be a box at that door, a box at that door, and a box near this door, probably on the stage. So as you arrive, all you need to do is drop your problem set in there. Don't worry about trying to sort it by your GSI. We will take care of that. Simply make sure that you have the correct GSI's name on your problem set. Do not put discussion section 115 or Monday, Wednesday at 2 o'clock. We need to have the GSI's name. If you don't know your GSI's name, introduce yourself to them the next time you see them. Look it up on Fairfax or the schedule. Do something. Ask somebody else in the discussion section. You can use their first name. You can use their last name. You can use their last name with a comma and their first name. Or their first name, no comma, and their last name. We don't care. We just simply want your GSI's name on there. We also need your student ID number. Otherwise, we can't record your scores. Now, the directions to the problem sets are on the front page. So just to review those very quickly, you must complete the problem set on the template that I posted. It's a Word document, so download it. Your explanations must be word processed. That's why you have to do it on that template. Your diagrams can be drawn by hand, which may mean that you have to write your answers, word process your answers first, and then print it out to finalize your problem set as you draw your diagrams. Your problem set must be stapled in the upper left-hand corner. That does not mean a paper clip. It doesn't mean a pressure clip. It doesn't mean a folder. It doesn't mean folded down and torn. It means stapled. So all of those things need to be done. Now, in terms of answering the problem set, your multiple choice questions must be computer highlighted, right? So you mold it and you highlight it and you highlight it, right? Whatever that's called. Okay. Your analytical questions, when you're reading them, analytical questions almost always have 3 parts to them. Part A and B is, here's your initial setup. A generally says, draw the diagrams, and it tells you what to draw based on the information that's in Part A. Part B says, tell me what's going on here, right? So this is what we call an economic explanation. Part C and D go together. This is where a shock will occur. You have to figure out what the shock is and how it affects your diagram for Part C, and then you have to write about it in Part D. You need to tell me what happened and why it happened, right? And then there will be a Part E and F beyond that, which is the third part of the question, right? Another shock is likely to happen, so you need to show that in the diagram, and then again, you need to explain exactly what's happening. The question is written in a way to be both sequential, one part follows after the other, and cumulative, right? So A gets you started, B, something happens, then C happens, or the third part happens. That third part's happening after the second part has happened, right? So it's a build on. Don't go back to the beginning and show me just that third part from the beginning, okay? So that's the way all of this works. Also, if 2 things are happening in a given time period, you should show the intermediate effects as well, right? So show me the intermediate effect and also the final effect. Now, the way that I identify what happens when, I always use zeros for the initial setup. Time period 0, year 0, however you want to think about it. What then happens with the shock takes place in period 1. So I use a 1 to identify everything, whether it's the supply curves, demand curves, whatever it might be, economic output, wages, whatever. And then in the second shock, which is generally part E and F, I use a 2 for the second time period or the second shock. If you also do that kind of numbering, it'll make it much clearer as to what happens in what sequence. If there is an intermediate effect, I typically use letters after the number. So an intermediate effect might be 1A, where the final effect would be 1. There might be a 1A and maybe a 1B if there are 2 intermediate effects, and then show the final effect as 1. Okay? So we want you to try and label things as clearly as you can. This will help you in terms of analyzing the questions. It'll also help your GSIs in terms of grading them. Okay? So that's what your problem set on Tuesday will need to look like. There's no football game this weekend, so you got plenty of time to work on it. Okay, so let's continue our discussion from Tuesday. Recall what we were chatting about is how do we determine what happens to real interest rates? How are they determined and what causes them to change? We saw that this is nothing more than a supply and demand analysis, right? We've got a supply of loanable funds, which is how much national saving is taking place in the economy. And we saw that that supply of loanable funds was a positive function of the real interest rate. It's a supply curve. It slopes upward relative to the price. The price of borrowing is the interest rate. Right? So as the interest rate rises, the cost of borrowing increases. People borrow less money because they borrow money to spend it. If borrowing goes down, spending goes down. If income has stayed the same, that also means that saving has gone up. Okay? So that's why we have a upward sloping supply of loanable funds curve. We also have a demand for loanable funds curve, which is basically telling us something about the borrowers. Right? What is it that they borrow and how are they related to the real interest rate? And we argued on Tuesday that that demand curve would be downward sloping, like almost every other demand curve. As the real interest rate goes up, again, the cost of borrowing has increased. Businesses will now borrow less and invest less. So the demand for loanable funds, or the desired investment curve, will be downward sloping. In a closed economy with no international trade, the real interest rate will be determined by the intersection of the demand for loanable funds and the supply of loanable funds. And that gives us our equilibrium real interest rate. And then finally, we saw that if there are different shocks to the economy, that is an exogenous variables that's changing, either the supply of loanable funds or the demand for loanable funds functions will shift. And when they do, the price of loanable funds, the real interest rate, will also change. Today, what we want to look at is essentially 2 things. We want to look at, first, what happens in an open economy where we do have imports and exports. And then second, we want to look at how, it doesn't say number 4 on there because I forgot to put it on, but number 4 is basically how are the funds that are saved actually transferred to the people who want to borrow it. So we've got this magic interest rate that's going on, but we want to think a little bit more about the process by how funds actually move from the people who are saving to the people who are borrowing. So that's the second big thing that we're going to do. Now, open economies. We talked about a closed economy, so you can figure out that an open economy must be one in which exports are positive imports are positive, and therefore net exports are positive, negative, or could be magically zero. The zero case isn't very interesting, so we normally think of net export surpluses and net export deficits. Now, when we bring net exports back in, our national income identity goes back to the original formula that we had at the beginning, in which case economic output is equal to consumption plus private investment plus government purchases plus net exports. Our saving identity, national saving identity, is exactly the same. National saving is economic output minus consumption minus government purchases. We can take the right-hand side of our national income identity, consumption plus investment plus government purchases plus net exports, substitute into our national saving identity, and what we would end up with is our net capital outflow identity. Net capital outflow identity. Now remember, this capital outflow is financial capital that's flowing out. Okay? So in this case, net exports is equal to national saving minus domestic investment, private investment. Okay? Now one assumption that we're going to make, just to keep the analysis on the easier side, is an assumption about perfect capital mobility. Perfect capital mobility. What we mean by perfect capital mobility is that there are no restrictions on the movement of funds between countries. That is, the country that is receiving net capital inflows has no restrictions on that money coming in. And that the country that is experiencing net capital outflows has no restrictions on sending funds out of the country. Yes? Okay, so good question. So the question was, what do we mean by restrictions? Do we mean things like tariffs, or do we mean things like the ease and speed with which we can move money around? So what we mean by restrictions here is that the government has not imposed any controls, whether those be taxes or regulatory controls, on funds either leaving the country or coming into the country. Remember, these are financial flows that we're talking about. So whatever the speed is of doing that is whatever it is, but that's not what we mean by perfect capital mobility. Now, not every country in the world has perfect capital mobility. In fact, to get as close to perfect capital mobility as we can, there are actually very few countries that have this. But the United States, Canada, Western Europe, Japan, Australia, all have something that approaches perfect capital mobility. On the other hand, China does not. The Chinese government imposes many restrictions both on funds leaving China as well as funds coming into China. We'll talk about what happens when you have capital controls, some sort of restriction on the flows in and out, but we'll talk about that later in the semester. One of the things that perfect capital mobility does for us is that it opens up an arbitrage opportunity between countries. So we want to think about this both from the saver's perspective as well as the borrower's perspective. So suppose before we open it up, that is before we have perfect capital mobility, we have a country that has a domestic real interest rate of 5%, while the real interest rate in the rest of the world is 8%. Right? So 8% in the rest of the world, 5% domestically. What would happen if those restrictions on capital flows now disappeared and we have perfect capital mobility? So think about the savers in the domestic economy. Well, I could leave it here and earn 5%, or I could send my funds out of the country and earn 8%. What do? You invest abroad. Right? Now, suppose you're a borrower. Right? If you're a borrower in the rest of the world, you have been borrowing at 8%, and now you see this country opens up where you can borrow money at 5%. So what happens? Borrowing inside the country would go way up. So we reduce the supply of national savings domestically and increase the demand for that country's saving. Its interest rate's going to go up. Right? Reduce supply, increase demand, the real interest rate will rise. How high will it rise? With perfect capital mobility, the domestic interest rate must go to the world interest rate. It'll go to 8%. The same thing is true if the reverse is taking place. If the country has a real interest rate of 8% and the world interest rate is 5%, and now we have perfect capital mobility, savers in the small country, did I say that backwards? If the interest rate in the rest of the world is 5% and the interest rate in our domestic economy is 8%, savers are going to want to move their money in one direction, borrowers in the other direction, and again we end up with a real interest rate in the country that's exactly equal to the real interest rate in the rest of the world. Okay? So what that tells us then is with perfect capital mobility, the interest rate in our country must equal the world interest rate. Must. That's what arbitrage does for us. Now, we can think then how this affects various types of economies. So we actually want to think about two different types of economies, what we call small open economies and large open economies. Well, we already know what open means. Open means we have net exports, and we also have international capital, financial capital flows, either in or out, with perfect capital mobility. What we mean by small is that the country's international financial flows are so small relative to the size of the world's international capital flows that whatever happens inside the country doesn't matter. It has no effect on the world interest rate. So in essence, every small open economy is a price taker, not a price setter. Right? As we saw in microeconomics, right? Price takers take the price of the product as a given. They have no influence on they have no influence on the world or the market price, or in this case, the world price. This allows us then to take the world interest rate as a given. With a small open economy, the world real interest rate is an exogenous variable. The world real interest rate is an exogenous variable with a small open economy. Now, we also want to think about where our closed economy interest rate, remember that's simply the interest rate that tells us where the supply of loanable funds exactly equals the demand for loanable funds, where that interest rate is relative to the world interest rate. We could be higher, we could be lower, we might be magically right at it. Okay? So here's an example of a small open economy where the interest rate for the economy in a closed situation would be at R0. Now, that might also just happen to be the world interest rate, but if it was, it wouldn't be very interesting. So let's assume for the moment that the world interest rate is at RW. And what we want to know then is what happens in this small economy once we adopt perfect capital mobility and we allow funds to move freely in and out of the country. So we've already argued that arbitrage tells us that the interest rate in this small open economy will immediately move to the world interest rate. As that happens, that higher real interest rate increases the cost of borrowing. Consumers borrow less. As they borrow less with the same income, their saving will rise from S0 to S1. Notice I use zeros and ones. At the same time, that higher real interest rate also makes the cost of borrowing higher for businesses. They borrow less, and then they invest less. So investment activity falls from I0 to I1. Now, we've got this gap here between saving and investment. We have to figure out what that is. Well, remember, we have our net financial capital outflow identity. So we know that saving minus investment is equal to net exports. So this is net exports. And as we can see, we're saving more than we're investing. The supply of loanable funds at this world interest rate is greater than the demand for loanable funds inside the economy. So net exports will be a surplus. So notice then we have a net export surplus, or a trade surplus, or a current account surplus. But this also means we have net financial capital outflows. So that excess national saving, excess over and above the amount that is being lent out to domestic borrowers, needs to go somewhere. And so it's going to borrowers in other countries. So financial capital is flowing out. As we said earlier, this is also a net foreign lending or net foreign investment. Remember, all of these terms are used interchangeably. And they all occur because at that real world interest rate, national saving is greater than private investment. So the excess saving, national savings, gets lent out abroad. Now, let's think about a second situation, in which case, once we open it up to international trade and perfect capital mobility, we just happen to be right at the real world interest rate. And you can see it's a really boring situation because we have no net exports. We do have exports. We're an open economy. We do have imports, but they would match, and net exports would be zero. Okay, not very interesting. Whoops. Now, let's think about a third situation, in which case our closed economy interest rate would be above the world interest rate. Now, once we open up the economy and have perfect capital mobility, our interest rate is going to fall to the world level. As the interest rate declines, consumers will borrow more funds, increasing spending. With a given level of income, saving will go down. So saving will fall from S0 to S1. At the same time, as interest rates and the cost of borrowing decline, businesses will want to borrow more. And so investment will increase from I0 to I1. And we now have this difference, which we still know will be net exports. And looking at our saving and investment diagram, or net capital outflow equation, we see that saving minus investment is negative. So it also implies that net exports must be negative. So we now have a net export deficit. We also have net foreign capital inflows. Or net foreign borrowing. Again, we can use all three of those terms interchangeably. So this slide simply summarizes what we've just seen. If the world interest rate is below the interest rate at which saving